Hello everybody, Sudhir Voleti here. Namaste, salam, sat sri akal. This is the app navigation video for my recommendation systems app, and this is only for an adjacency matrix input. All right, so first we launch the recommendation systems app using your zero code learning credentials. And once you launch the app, we will examine the app layout. So let's get there. Uh, okay. This is my zero code, as you can see. Yep. I have logged in, and in my apps, there is the recommendation systems app. There is the recommendation systems app. I am launching it, and it will launch like this. Yeah. Okay. Note that there is one input field for the main file, and then you have five output tabs. Okay. Five output tabs. All right. So five output tabs, one input field. Okay, now for the data, please go to the overview and example data set tab, the first tab. Here you find this download sample text file. Please click on it. Okay, it will download. I mean, I have already downloaded. It is downloading again, but there it is. Okay, it downloads typically to your downloads folder, yeah, wherever it normally goes. Okay, so there it is. And then we will load this downloaded file into the, so now please come here, go here, and this is my downloads folder. This is the file I just downloaded, and I am uploading it now into the app. Okay. All right, now that we are done with this, please go to data summary tab, the second tab. Okay. Now, the moment you come to data summary, please note that the input fields have changed. We won't be needing these, yeah. Okay. This here, sample data set, shows you a sample, the first few rows and columns of the data set. Now, this data set has 241 rows, 303 columns. This is from a survey that I took in my class. The row names are people. These are people. These are their nicknames that they chose. And these are the B2C brands that they said they liked. Okay. So a 1 here would mean that user Sheldon liked the brand Nike. User Sheldon also seems to like the brand Amul. User Sheldon does not or has not said anything about OnePlus and so on. Okay. All right. So there are 241 such users and 303 such brands. Now, please check on this. And the moment you check on this, those other fields disappear and this button comes. Please click on the button. And basically, it creates an adjacency matrix and uploads it. It will create a person to person, user to user adjacency and a item to item adjacency. Okay. All right. Now we go to the next tab, IBCF recommendation. Just give it a few seconds and it will basically impute and give you a result here. Okay. All right. So this was the data summary tab. Remember, we the input file is a DTM, document token matrix. Now this is coming from the basic TechStan app, which is also present in this channel. Yeah. Bipartite graph, basically the document token matrix is a bipartite graph. The documents are the users, the tokens are the brands. And why is it important for us? It becomes important because I can make adjacency matrices out of a bipartite graph. All right, and so we did this, yeah, we created the adjacency matrix. At the back end, our algorithm is going to try to compute or impute the likelihood of a user liking any item not already liked in the set. Okay, two ways to do this, and these correspond to IBCF and UBCF approaches shown in the app. We will see this. Okay, all right. Now let's go to IBCF recommendation tab. So you come here. Please note that there is a drop down and all 241 user names are here. So you can choose any of them. Okay, you can choose Sheldon, for instance. It will show you recommendations for Sheldon. Let me go with Hulk for now. Okay. So under IBCF scheme, the machine is saying that user Hulk is likely to like Nike with a 60% probability, Amazon with a 58% probability, and so on. Okay. This is the frequency of occurrence of these brands in the corpus, and this is the free rank based on the frequency. Okay. Let's take another user, Phantom. This is what that person is likely to like. Okay. All right, now let's go to UBCF, and you will see UBCF has a very similar format. You can select your user, and you can select, your brand. I mean, you can select. So this is based on which users are similar to Bubbles and the kind of brands they liked. I mean, that's basically where this is coming from. UBCF will have a much lower probability. It's an indirect likelihood computation. And you will see also that the last tab is similar users, which basically says which other users are very similar to Bubbles in terms of the brand preferences that they have expressed. So these are the people who are most similar to Bubbles. If you go, let's say, Supandi, these are the people who are most similar to Supandi, and so on. Okay. So that's basically it. Let me quickly walk you through this. Okay. So we did IBCF, and I said UBCF also relies on, well, unlike the IBCF, UBCF relies on inter-user similarities. The last tab is similar users, and we also explored that. Okay. Well, with that, this app navigation video comes to an